So hello everyone, today we are going to start Striver SDE set challenge. Basically I am doing challenge, but I thought I already have solved plenty of lit code problems, but I am preparing for my placement. So I am revising the particular problems. So I thought why not to try interview style explaining by approach. Basically if you see, the best person who can teach DSA is absolutely Striver. No one can teach algorithms better way than Raj Vikramaditya. But in very few weeks I am going to appear for interviews, so I thought let's give a try. So going ahead, today's first problem is add two numbers. No, I think the first problem was remove nth node from AND list. So the most obvious solution we can think of is first find the length of entire linked list and remove length minus n plus 1th node, right? This is quite good approach, order of n, basically where n is number of basically size of the linked list, but we can do in single pass. If we do by length we have to take two passes, but we can do by single pass, and we can do by taking two pointers. Let's suppose I give the name slow and fast. The first one will be n node ahead of slow pointer at any given time. So basically if my slow pointer is pointing at this particular node, my fast pointer will be pointing to two node ahead, basically at third number of node, right? Now I will move my fast pointer to the last node, so my slow pointer will be at this particular node, which will be, if you see mathematically, it will be length minus nth node, length minus n node. Basically the node with the previous node which we supposed to delete, right? In this case we have to delete 4, but our slow pointer will be pointing at this particular node, so we can simply delete by assigning next to next, right? And there can be a corner case where deleting node will be at this particular case, right, at head. Basically whenever we are given n as the size, our first pointer will be here and slow will be here, and we will delete, right? But if we delete we will lose the access of head. In this particular case, to handle this particular edge case, we are taking the count of dummy node. Basically we are appending a dummy node so that even if this particular edge case come, we can easily deal with it, right? So let's directly start coding. Let me check if node can be null. No, node cannot be null. Basically linked list can't be empty, so we don't check this particular edge case. Let's create list node dummy equal to new node, new list node. Let's assign some value as -1, and its next we can also give you, right? Yes, we can give. So let's give it as read. Now let's take two pointer, list node star slow fast. let's both point to dummy. And as I discussed, I will move this particular fast pointer n step ahead. Basically, if it is currently at 0th index, it will be at n plus 1th index. So yes, let's do it. Fast is equal to fast next. Now while fast not equal to null ptr, okay, we just move both pointers slow and fast one step ahead. And our slow will be pointing at where it should be pointing. Basically, for deletion we need the access of previous node in single linked list, so our slow pointer will be at its correct position. We just simply update slow next is equal to slow next and return dummy next. Our code is complete. We are just using 3 pointers, basically order of n. Okay, I have to put star here. I think major problem, I guess. Oh, I forgot int. Yes, let's try to submit and see. It should be working completely fine. Yes, it is working. So now let's add 2 numbers. Basically list is given in the reverse order, so no worries. Again we are doing same thing. We are creating a dummy node. We know we need 2 pointers, or we just simply use L1 L2, we don't care. Let's define a variable int sum is equal to 0 and int carry equal to 0 while not, or basically while L1 and L2 basically both don't become null. We see if L1's, oh actually we don't need this particular thing, right? It is code of merge to list of what I am doing. So just simply do sum plus equal to L1 val plus L2 val. We need a temporary pointer. Let's name as TP, which will be pointing at the last node of dummy. So dummies next, we are going to append a new node, list node, new list node, and its value will be sum modulo 10, not dummy is next, its TP is next. TP. Let's increment our TP counter, TP variable basically, TP2, TP next, and char equal to sum divided by 10. Since why I am doing modulo, basically it is accumulating particular digit, let's suppose 4 and 6, right? Its sum is 10, so I will take only the digit, last digit, the units place, which is 0, and the particular tens place, which is 1, will be added to carry. If yes, it is it. No, actually it should be sum plus carry. I missed something, right? You're right. And sum plus equal to carry. No? Oh yes, I have to add carry here. Otherwise, what is use of carry? Right. Now, while there may be a case it is given that both will be of same length, no, not given. Here example is that one list become empty earlier. What to do in that particular case? Basically do this thing. If only one is there, add its digit with 0. Basically just avoid the other. I need the entire thing. Just remove here L2. The same will be done for L2. Increment both pointers. I forgot this particular step, which is not acceptable. L2 is equal to L2 next. Here only L1 will be incremented. Here only L2 will be incremented. If carry is there, TP is next is equal to new list node star, no star here, new list node carry. Done. What we have to return eventually, the dummy is next. Oh yes, I have to write new keyword and to find this particular thing. What happened? Yes. It is giving wrong answer. Let's debug. It is adding 2 times 7. No, it is not correct. Okay. Let's see. if we are doing we are adding carry, we don't need plus equal to actually. I am doing plus equal to. Yes, it is problem. Basically, I am doing plus equal to. I am continuously adding all previous digit, which is not the case. I am just adding this particular digit and the carry come from the previous digit. That's it. Let's submit. Runtime error. Null pointer accessed. Oh, here L2. Yes, done. And so the super easy question of today, delete the single node. So we are given this particular node, and what we can do is we just simply copy the next value of this. Since we are clearly given, you will be not given the sorry, where is the guarantee? Yes, it is guaranteed that the node is not the last node. Since it is not last, what I'm saying, since it is not the last node, we always have one node ahead of this particular thing. So what we can see is we need the next value at current node, right? But we only have access of current node. So if we see the algorithm of deleting the node, which is stop at the previous element of the node which supposed to be deleted, and manipulate the previous one's pointer to do this thing, but we cannot access in this particular list. So what we are doing is we just copies the next value and just skip the next node. Copy the next value, which is 9. I will copy and I will just skip this. So I will basically delete this node instead of this. By this I am removing one node which is supposed to be this, but instead of deleting I am just replacing the values. The code is very simple. Node val is equal to node next val, and nodes next is equal to node next. Just 2 lines of code and the problem must be solved. So yes, this is the day 10 of Striver's SDE set. I hope you guys like this particular video if you are watching. Thank you everyone. Thank you very much.